All right, today we'll be looking at our day three notes on bearing. Bearing is kind of a term used in navigation and it has other definitions as well. But the one we're specifically going to be talking about today is kind of like what's called absolute bearing. Bearing is the number of degrees clockwise that an object is heading from due north. So if we think about, this is kind of helpful, north, east, south, and west. And if you think about a circle being 360 degrees, then north is basically saying you have gone 0 degrees clockwise, like so you haven't moved at all. Or if you've gone around the full circle, you've gone 360 degrees. If you head to east, that's a fourth of a circle, or that's 90 degrees. If you go south, that's basically saying you're going 180 degrees, or on a bearing of 180 degrees. If you're going west, that's 90, 180, and then west would be 270 degrees, and then again, all the way would be 360 degrees, which basically says you're still going straight up. And halfway in between there, sometimes it's kind of important to know is that halfway in between 0 and 90 would be 45 degrees if you cut it in half. Halfway in between 90 and 180 would be 135 degrees, again splitting that 90 degrees into two. So half would be 45, so 90 plus 45 is 135 degrees. 180 plus 45 would get you to 225, and 270 plus 45 would get you to 315 degrees. So when we're looking at something, let's say I wanted to talk about heading on a bearing of 150 degrees, it'd be like, okay, it's somewhere in between 135 and 180, a little bit closer to the 150 or the 130 than the 180. So that's what we'll be thinking about in terms of degrees, and we'll come back to that. So it says draw an object that is moving on a bearing of 40 degrees, 160, and 200. So if I just have an object, and if I imagine due north being straight up, this line doesn't really exist, but I'm just imagining that being due north, then an object heading 40 degrees, well, if straight across would be 90, half of that would be 45. A 40-degree angle, that means this object is moving kind of on a path that's somewhat like this. Okay, so this would be 40 degrees clockwise from due north. So the object would be heading in that direction. An object that's heading in 160 degrees, again, if here's 90, 180, 160 is kind of somewhere down there. So if I imagine due north again, that line's not really there. I'm just using it to help me imagine it. Here's 90, 180 is straight down. So 160, this object would be traveling on a path somewhere down there. And then 200 degrees, if 180 is straight down, 200 is going to be a little bit past it. So if I imagine due north, and again, this is saying you've gone 160 degrees from due north. So on a bearing of 90, not quite 180, but 160. And 200, well, straight downs would be 180, so 200 would be heading in a direction somewhat like that. And that we would say is 200 degrees from clockwise, give or take. So depending on, those are the directions you're heading. So that's kind of the definition of bearing. We'll do a few problems where we basically set up a right triangle with bearing. They're not always going to be, you're not always going to be traveling at right angles, but for these problems, until we have the ability to deal with triangles that aren't exactly 90 degrees, which we will after this section, then we kind of have to make right triangles. So a plane travels 100 miles on a bearing of 90 degrees and then turns and travels 120 miles on a bearing of 180 degrees. Find the bearing from where the plane started to where it ended. So we're going to unpack this one line at a time. A plane travels 100 miles on a bearing or at a bearing of 90 degrees. So again, think about, here's north, east, south, west. North is 0 360. East would be 90 degrees, heading south is 180 degrees, west is 270 degrees. And again, you haven't gone at all, or you've gone a full 360 to get back to going up to north. So if I have a plane, just make a dot. So here's a plane, and it says I'm heading 100 miles on a bearing of 90 degrees. So if I imagine due north, 90 degrees would be straight to the right. That is 90 degrees. So far my plane has headed this way, and it said it did it for 100 miles. Then it turns and travels 120 miles on a bearing of 180 degrees. So if I start at this where I've ended up now, and if I imagine again right here, due north, so a line going kind of straight up, 180 degrees would again be going straight down. So now I'm turning to go straight down, and it goes 120 miles. So this angle right here is a half circle, or 180 degrees, so I know I'm heading straight down now from due north. And then it says, find the bearing from where the plane started, so the plane started here, to where the plane ended up. So if I kind of connect this line right here, the bearing that this plane did, it started, from due north. It not only went this distance, which is that 90 degrees, but also continued that little angle right there. So if I think about the bearing, find the bearing from where the plane started to where the plane ended, that's this piece right here. So here's the imaginary due north, and then I want to know, the plane started here, went to the right, went down, stopped here. What is this entire angle? And so there's two pieces to that. There's the piece that is the 90 degrees we already know, and then this angle x, which we're going to find. So to do that, I'll use my trig. I know that this is a right angle. There's a couple ways I know that. One, it kind of looks like it, but two, if I went 90 degrees this way, then to go 180 means I have to go another 90 degrees. So if going straight east, this was 90, to do 90 more, to get to 180, I had to go another 90 degrees, basically. So I went 90 from here, and then I went another 90 that way. So this is a 90-degree angle. What else? That's it. So I have my triangle. I want to figure out this angle right here. We'll call it x. This is 100. This is 120. Mark it. Here's the hypotenuse. Here's the adjacent. And here is the opposite. So I want adjacent and opposite. So that's going to be tangent. So tan of x is going to equal TOA. So TOA opposite over adjacent. So TOA, SOHCAHTOA, so opposite side over the adjacent side. Solve for the angle, take the inverse. So inverse tangent of 120 over 100. Let's see, I'm in degree mode, inverse tangent of 120 over 100 gets me 11.31, 120. Gets me 50.194. So again, this is not my final answer, because saying you travel on a bearing of 50 degrees would mean I would be going at somewhere like this direction, which is not what the plane did. So I have to realize that, again, I went 90 degrees to kind of start, and then I went down some. So altogether, from where I started to where I ended, that's the 90 degrees plus this 50.194. So the 90 plus the 50.194. So 90 plus 50.194 degrees gets you 140.194 degrees. So that's the bearing you're traveling on, a little bit less than 180, and just a little bit more than that halfway point, that 135. All right, number 3. The bearing from point A to point B is 270 degrees. So let me just start out. I got a point A, and I'm going to point B. So if, again, 0, 90, 180, 270. So if I'm traveling 270 degrees from due north, here's 90, so 90, 180, 270. That means that I am traveling to the west. So from A, this angle is 270 degrees. So from due north, 270 degrees, that means I'm heading west. So that's to go to point B. And then I'm going from B to C is 360 degrees. So if I'm this point B, and to go 360 degrees means I'm going around the circle and basically going straight back up. So I'm going up to get to C. The distance from A to C is 10 miles, so I know this distance is 10 miles, and the distance from B to C is 3 miles. Find the bearing from A to C. Okay? So let's think about what that looks like. If I think about, say, due north right here, to go from A to C would be all the way here, which I already know is 270. And then that last little part to get to C, that's going to be this angle in here. So really, I want to find this angle, call it X, and once I know what X is, if I add that to 270, the bearing, so from due north, from A to C, is around the circle, 270, plus whatever X is. So from X, this would be the opposite side. This would be the hypotenuse. So I want opposite and hypotenuse. Sine of X equals 3 over 10. So X would be the inverse sine of 3/10. And that is inverse sine of 3/10 gets you 17.458. So 17.458 degrees. So we had 270 degrees plus 17.458 degrees. That ends up being 287.458 degrees. So again, the important thing is just to remember always wherever you're starting out and it says bearing, just imagine a line going due north and figure out what that degree is. So this one, the bearing from A to B is 180 degrees. So from A, messy handwriting today, from A to point B. So if I'm A and I want to travel on a bearing of 180 degrees, here's due north. Going straight down would be 180, so I'm going down to point B. And then the bearing from B to C is 90 degrees. So if I imagine again this like imaginary line traveling 90 degrees would now be going to the right. And then the bearing from A to C is 140 degrees. So the bearing from A to C is 140. So let's see, from B to C was 90 here. So what this is saying is that, okay, I know that this portion right here, if I went straight to the right, that is 90. That's a 90-degree angle. 140 or 180 would be straight down. So this angle kind of right here. So this would be going 90 degrees. And if I tack on this piece as well, this is the bearing from A to C, and that tells me that's 140 degrees. So how is that useful? Well, if I know this piece is 140, to get to 180, a half circle, that this must be 40 degrees, because 140 and 40 gets you 180 degrees. So I now know that this angle must be 40 angle A. It also told me AB is 4 kilometers, and then asked me to find what AC is, the hypotenuse. So here's your 90, here's the hypotenuse. From this angle, this must be the adjacent side. And I want to figure out the adjacent and the hypotenuse, relate those. So that's going to be cosine. So cosine of 40 equals the adjacent side over the hypotenuse. So multiply by x on both sides, divide by cosine of 40, and you would end up with x equals 4 divided by cosine of 40 degrees. So you can just flip them if you remember the shortcut. So 4 divided by cosine of 40. 4 divided by cosine of 40 gets us 5.22. 222. So this side from AC is 5.22 kilometers. And then last one. A boat travels for 42 miles on a bearing of 125 degrees. So let's see, here's 0, 90, 180, and halfway in between 90 and 180, if I'm going 90 each time, be 45, so that'd be 135 degrees. So 125 is going to be something like that. So a boat travels on a bearing of 125 degrees. So let's travel 125 degrees, so 180, 190, 125, let's say is something like that. So it travels that direction. Then turns and travels 15 miles on a bearing of 215. So from this point, this new point where it's turning, I have to go 215 degrees. Well, here's 270, and then here would be 225. So I've gone 45 degrees, so 215 be somewhere, something like this. So there's 180, and then a little bit extra gets you 215, and it does this for 15 miles. What's the bearing from where the boat started to where it ended? So the bearing is where it starts. So it started here, and then it ends here. So I want to know what's the bearing from here all the way down to basically here. Okay, so I'm going to connect this line. And I was told that he traveled 42 miles in that direction. So this was the 125. And then from here, he turns and does 215. So normally we would say like, well, how do I know this is a right triangle? Because all my trig relies on being on a right triangle. And it looks like it, but how do I kind of know for sure? Well, the one way to tell is the fact that if you've gone 125 degrees, and then all of a sudden you go from 2 to 215, you change that direction, the difference between 215 and 125 is 90 degrees. So you've made a 90-degree turn, essentially. That's how we know we're dealing with a right triangle. So what angle do I want to know? Well, sloppy handwriting. This is where I end. So again, if I imagine where I started from, so here's the beginning, and I want to know what's the angle. Well, I went this far, and then I'm going this far. So I know that first piece is 125 degrees. I need to figure out what this angle is right here, so that would be the bearing I'm on. It looks like it's almost 180, but it's not quite. It'll probably be pretty close. So I care about the adjacent side. and the opposite side from this angle x. So that's going to be tangent. So tangent of x equals opposite TOA, opposite over adjacent. So x is going to be inverse tangent of 15 over 42. Inverse tangent of 15 over 42 gets me 19.654 degrees. 19.654 degrees. And if I add that to my 125, that's going to put us at 144.654 degrees. So that boat's traveling somewhere around, right around here. Okay. All right, that is it for bearing. So things to remember, just imagine that line going due north and then have that northeast, southwest kind of guide to help you out a little bit.